Okay, today we are going to discuss the topic of periodic table, that is elements are classified into blocks based on the differentiating entering of differentiating electrons based on the entrance of differentiating electron into different orbitals. Elements are classified into mainly four blocks. Those are S block, P block, D block, F block. Already we studied the first S block elements we studied, and also we have written notes also. Then second one is P block, that is also we completed. Then today I am going to teach the following block, that is D block elements. Okay. So in order to understand the D block elements, first of all, I give you for your clear understanding, I give you periodic table figure. See, you know already this. One more time you draw this. One more time you draw. You have to draw this figure one more time for your clear understanding. Okay. So the rough figure of periodic table will be like this. You know this already. We have drawn number of times. So you know already the left part of this table is S block. Okay. These groups are first groups and second groups. You know this. Okay. And the complete right part of this table is P block. This is called P block. This is S block. This is P block. So P block started from 13th group to 13th group to 18th group. Okay. Then in between S block and P block, in between S block and P block, there will be D block. Okay. In between S and P block, there is a D block. So D block groups are total of 10 groups. They are starting from third group to 12th group. Okay. So here the entire 18 groups divided into A, B subgroups that already we discussed. And under the table we have a block. Okay. This table you have to draw this. Okay. So after completing this, in last class I explained S block, P block, definition of S block and P block. Then now we are going to define the D block elements. You write down what do you mean by D block elements. So how can you define D block elements? The first thing is, what is the definition of D block elements? This is the first one. And what the groups we consider block element and what is the position in the table, that all the things we will discuss now one by one. So you write down the definition. D block elements means, write down the elements in which differentiating electron or electrons, whatever it may be, differentiating electrons enter into differentiating electrons enter into differentiating electron enter into n minus 1 d subcell. So n minus 1 d subcell means, this is penultimate cell. So here elements in which differentiating electron enters into n minus 1 d subcell. That means there is a entering of electrons into d orbital of penultimate cell. Enter into n minus 1 d subcell or d orbitals of penultimate cell. Penultimate cell. Penultimate cell are called d block elements. Are called d block elements. Okay. See, the main difference you have to remember, differentiating electron, if a differentiating electron enters into s orbital, those are s block, or differentiating electron, the last coming electron enters into p orbital cell, those are called p block, no? In the same way here, differentiating electron enter into n minus 1 d subcell. That is nothing but d orbitals of penultimate cell. Penultimate cell means, the cell before the valence cell is penultimate cell. I already told so you write down. Okay. Their valency electronic configuration. Their valence electronic configuration. This is very important. You remember, their valency electronic configuration is n minus 1 d 1 to 10 ns2. Thing you have to remember. You should practice number of times. This is a very important thing. What is the valence electronic configuration of d block elements? N minus 1 d 1 to 10 n. Here you know this n is valence cell, n minus 1 cell is penultimate cell. Okay, just you look here, look at the board. Here particularly the groups which are started from third groups which are started from third group to 12th group. Complete these total of 10 groups are nothing but D block, So you write down that point. The total of 10 groups, which are started from third group to 12th group. Started from third group to 12th group. Third group to 12th group are called D block elements. Are called D block elements. Are called D block elements. Okay. So one more point you want to write here. D block elements contain 4, 5, 6, 4, 5, 6 and 7 periods. 7 periods. But last Seventh period is incomplete. Seventh period is incomplete. Okay. So here I give you clearly. Have you written this? I want to remove this one. Completed. Okay, here I show here. Third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. See, these groups also named like this: third B, fourth B, fifth B, this is sixth B, this is seventh B. Okay, here this is eighth B, named as eighth B, and eighth B is subdivided into small a, small b, small c groups. I already told you earlier in earlier class I explained. Then this is named as first B, second. Okay, here in third B the first element is scandium. Then after scandium, you know, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, here atomic number is 21. Here zinc is 32. At least you have to remember this is this first line. Okay, this is called what? This series is called fourth period. This is called fourth period and 3D series. 3D series. Why it is called 3D series? You try to understand why it is called 3D series means here the differentiating electron entering into 3D orbital. No? 3D orbital means that means differentiating electron, last coming electron enters into 3D orbitals. That's why this entire series is called 3D series, but actual period is fourth period. Actual period is fourth period. Okay, here the next, in third B, the next element after scandium, the next element is yttrium, and the last element is cadmium. Okay, I write here atomic number for your future purpose. I write here. Just you should practice, and it will come in your higher classes. Higher classes it will come. Okay, cadmium 48 atomic number. Then next, this series we call as what? Fifth period. This is called fifth period, and 4D series. This change you try to remember. Why it is 4D series? Here differentiating electron enters into 4D orbital. That's why it is 4D series. Enter the series, but the period is fifth period because this is penultimate cell. This is valence cell. So fourth means fourth cell next to valence cell. That's why valence if valence cell becomes fifth, then anti-penultimate cell is fourth. That thing you remember. Okay. Then after yttrium, the next one is lanthanum. Lanthanum 57. Lanthanum 57. This is called what? Sixth period. Sixth period. Series is called 5D series. 5D series. Okay, here actinium 89. This is seventh period incomplete. Seventh period incomplete. So look here, I write here seventh period, but the last seventh period is incomplete. This one. So this is also called what? 6D series. That means differentiating electron enters into 6D orbital. That's why it is 6D series. This row, entire row is called 6D series. Okay, here mercury, lanthanum, the series end one is mercury, 80. This is mercury, you remember, 80. Okay, Lucky, is it clear to you? Right. You want to remove this? Okay. Here, just one note you have to write for your future purpose. What is this? You write D block elements. D block elements can have empty d orbitals, empty d orbitals, empty d orbitals, empty d orbitals are called transitional elements. Are called transitional elements. Are called transitional elements. So what do you mean by transitional elements? Means if d block elements they have empty d orbitals, then those d block elements we call as transition elements. This will be understood in higher classes. Okay. Then after completing d block elements, then next to following block is f block elements. F block elements, you write out. F block elements. Okay, now I am going to define definition and the important points about F block elements. See, first of all, you have to learn what are F block elements. How can we define? See, the elements you write out. The elements in which the elements in which differentiating electron or electrons enter into n minus 2 f orbitals, n minus 2 f orbitals, or n minus 2 f orbitals of anti-penultimate cell. Anti-penultimate cell are called F block elements. Are called F block elements. So here you try to understand what I mean to say here. Here the last coming electron entering into f orbitals, no doubt. But those f orbitals belongs to which cell? Anti-penultimate cell. That thing you have to remember. So I told you in earlier classes, I have explained what is this. This is nucleus, you know, 1, 2, 3, 4, like this. Okay. Okay. So here this is the last cell, you know, nth cell. This is valence cell. This is called what? Yes, valence cell. So here n minus 1 cell, no, this is called what? Penultimate cell, PS. Penultimate cell. Here n minus 2, so this is nucleus, S, SP, SPD, SPDF. Okay, see, this is nth cell, this is n minus 1 cell, this is n minus 2 cell, this is APS. APS means anti-penultimate cell. So here the thing you remember, very important, try to listen carefully. SPDF, SPDF, okay? Here SPDF. We have these subcells like this. See, the thing you remember, the last cell we consider as valence cell, isn't it? Last cell is valence cell. The cell before valence cell, what is that? Penultimate cell. The cell before penultimate cell, what is that? APS, anti-penultimate cell. Here, how can you define a black elements? That means the electrons. Electrons means E minus electrons enter into n minus 2 f orbitals. You try to understand. That means electrons enter into n minus 2 f orbitals. If electron enters into n minus 2 f orbital, that element we consider a black elements. Otherwise, if electrons enter into n minus 1 d, that means this one, those are called what? D block. That thing you try to remember. Okay. For example, electron enter into s orbital, that is called what? S block. Or electron enter into p orbital, that is called what? P block. So here from this picture, we can able to understand each and every block. Listen and look here. Lucky, see, electron, this is electron, electron enter into s orbital of nth cell. So then it is called what? S block. S block. If electron enters into p orbital of valence cell, then that will be considered as p block. Understood? Then if electron enters into d orbital of n minus 1 cell, penultimate cell, then this is called what? D block. If electron enters into f orbital of n minus 2, that means anti-penultimate cell, then this is called what? F block. So this difference you try to remember, and it is a technical difference, somewhat it is a tough to remember. Even though you should practice number of times, you get perfection. Okay. So one more time I will explain. Listen carefully. If electron enter into s orbital of valence cell, those are called what? S block. If electron enters into p orbital of valence cell, that is called p block. Or otherwise, electron enters into d orbital of n minus 1 cell, that is p block. If electron enters into f orbital of anti-penultimate cell, that is called F block. Okay, I think have you understood? Okay, so now our topic is the F block elements. No, see, I write F block elements general valence. See, general valency electronic configuration of a block. General valency electronic configuration of a block is n minus 2 f 1 to 14 n minus 1 d 0 comma 1 comma 2 ns2. This is the important general valence electronic configuration. You read right number of times. Okay, please. One more point. One more point you write here. A block elements are divided into a block elements are divided into two types. Are divided into two types. So one section is lanthanides, which are also called 4F series elements. Lanthanides, which are also called 4F series elements. Okay, which are started from cerium to end with lutetium. Here, cerium is 58, atomic 58. So series is called 4F series lanthanides. They are started from cerium, end with lutetium. Okay, actinides. These are also 5F series elements. 5F series elements. Okay, which are started from thorium. These are so started from thorium, end with lawrencium. Here thorium atomic number is 90, lawrencium atomic number is 100. Okay, if you write its name clearly, because at this lower level it is somewhat hard to remember. So what is this? This is cerium. Name of this element is cerium. What is this? Lutetium. Okay, that means start with cerium, end with lutetium. That series is called 4F, also called lanthanide. So here this is thorium. The element name is thorium, the starting element. End with which element? Lawrencium. I write clearly. Please you note down. Lawrencium. Okay, here I give you two important notes. See, actinides are also called are also called radioactive metals. Actinides are also called radioactive metals. Radioactive metals. Radioactive metals. Okay, called radioactive metals. The thing you remember. This is enough at this stage. Did you write entire this part? Okay, then one more point I tell you. Incomplete. See, incomplete f orbital elements are called incompleted f orbital elements are called inner transitional elements. All these are examination and what is that IIT bits. Just you try to remember and try to by heart. I tell you here two things. What is that? Actinides are also called what? Radioactive metals. You remember this word, radioactive metals. And one more thing I tell you. If any element whose contains incomplete f orbitals, such elements are also called inner transition elements. Is it clear? You write. Okay. With this we completed blocks we completed blocks. That means scientists they divided elements into major four blocks based on their valency configuration. What are those? S block, P block, D block, F block? We have finished. That entire big topic is today we completed. The remaining part, following part, we will discuss tomorrow. Let us stop here. Thank you.